Hello there, Mr. Wilson here again for what is a brand new series on the channel. This is the Binomial Theorem, Part 1. What is the Binomial Theorem? So in this, we're going to talk about what is the Binomial Theorem and what's its purpose. Why do we even need it for GCSE Further Maths and A-Level Maths? Now, these videos are mainly going to be targeted towards GCSE Further Maths, but there might still be some stuff in here that is relevant for an A-level maths student who is also keen on learning the binomial theorem. So in this first video, I just want to look at what is the purpose of it and what even is it? Like, why does it help us with something? And I don't want to kind of reveal too much too soon. So before we even get into the binomial theorem, let us start off with actually do some expanding. So, well, first of all, we could expand double brackets. Now, many students who are studying GCSE Further Maths will be familiar with expanding double brackets. Now, we can use the grid method to expand these. So we could put them in the grid. And we write one of the brackets across the top and one of the brackets down the side. X times x is x squared. X times 1 is 1x. X times 1 another x, and then a plus 1 here. So this would be expanded x squared plus 2x, because there's two lots of x, plus 1. So that is the expansion of that. And quite a lot of students can expand brackets without using the grid. Some you like to use the FOIL method, which is first, out, inside, last, which is the same process as doing the grid, just not set out in a grid. Now, expanding double brackets is pretty nice. Okay, but what happens if we wanted to expand triple brackets? Well, if I wanted to work this out, then I could expand the first two, which I already know is x squared plus 2x plus 1. And then I just need to combine it with the third bracket, which is x plus 1. So I can again use the grid, but I need a bit of an extended grid this time. So I'm going to use this. I'm going to write x plus 1 here, and then x squared plus 2x plus 1, and I get x cubed, 2x squared, x squared, that's going to be a 2x, and that's going to be a 1. So my final answer to this is going to be x cubed plus 3x squared plus 3x plus 1. And that seems pretty fine. Okay, what happens if I wanted to expand 4 brackets? Right, I wanted to do x plus 1, x plus 1, x plus 1, x plus 1. Now you could go through the exact same method as what we've just done, because we already know that these three brackets will expand to x cubed plus 3x squared plus 3x plus 1. And all you would need to do therefore would be to use that answer with that bracket in a new grid and expand a fourth bracket. Okay, so what happens if I wanted to expand 5 brackets then? Well, I would need to know the answer of this one first, and then I could incorporate the 5th bracket. Now, instead of writing out x plus 1, x plus 1, x plus 1 all the time, I'm just going to write x plus 1 to the power of 5, right? Which means that bracket 5 times. Okay, what happens if I want to expand 6 brackets? Now you can very quickly see here that this is going to take a very long time. Like, the mathematics involved in this is not necessarily that tricky. You just have to be careful of some of the terms and making sure you're collecting all the like terms. But if you know the answer to the previous one, it's not tricky, so to speak. It's just quite time consuming, right? You know, it's going to take a lot of time and effort to expand these brackets, especially when we're, you know, expanding 5, 6, 7, 8, 9, however many brackets. And it's especially tedious given it's the same bracket over and over again. Would it be maybe easier if there was a way of expanding something like this, where you have the same bracket being expanded 5, 6, 7 times? If only there was such a way. Well, it turns out there actually is, and that is the binomial theorem, or that's the purpose of it anyway. So if we scroll back up, the word binomial, bi comes from an old word meaning two, nomial means terms. So the binomial theorem applies to anything that is in the form x plus y to the power of n, where x and y are two different terms. Now, these could be letters, so x plus y could be the setup for the binomial theorem, or it could be, as we've used here, x plus 1, or it could be 1 plus x, it could be x minus 3, it could be 4x plus 17. It can be anything as long as it's two terms only. That's how the binomial theorem works. Now, for GCSE Maths, Further Maths, this power is a whole number, right? So it's a whole number, positive whole number power that you are expanding by. Now, some people who are then listening to this as GCSE Further mathematicians might say, well, obviously it's a positive whole number. You could never expand something that is a negative 1 power or negative 2 power, because how would that even work? Well, you can expand with a negative 1, negative 2, negative 3 power, but that is far beyond the GCSE Further Maths. You can also even expand with a fractional power, so you can have really weird powers, such as 3/2, a quarter, in the binomial theorem. Now that is a whole different world. That is a whole other kettle of fish that I'm not going to get onto in this video, although it is fantastically interesting, and does use a formula, but is definitely far beyond the GCSE Further Maths. For GCSE Further Maths students, they just need to know the idea that the binomial theorem can be used for anything that is a positive whole number power and two terms in the bracket. If there were more than two terms, the binomial theorem wouldn't work, unless you can simplify it to two terms, then you could use the binomial theorem. So that is kind of what is the binomial theorem then. It is a way of expanding brackets that is more efficient, that is quicker, and that hopefully gets to the answer quicker than it would be for you to expand 5 or 6 brackets on your own. Now, I am going to leave it there for this part, although quite a short part. The reason for this is because I want to kind of break this down into multiple steps, because I want students to be able to pick where they're at in their learning journey. And I don't want to kind of cram everything into one video and then not allow students to be able to figure out where they're at and pick the appropriate video for them, rather than trying to look through a 40-minute video for one specific part that they want. So I'm going to wrap it up there for this video. If you've got any questions or anything like that, please let me know in the comments below. I would love to hear them. If there's any suggestions or papers or anything like that you would like me to cover, then also please let me know. But yeah, that pretty much wraps it up for this video. Please check out all the other videos, and my apologies that it's been such a while. I'm going to get back into it and start making some more videos. Also, apologies for not having a webcam in this video. There's some technical things I just need to iron out, but I just wanted to try and get back making some videos, which is the main thing. So, all I want to say is thank you so much for watching, and I hope you have a fantastic day.